Welcome to Bitunet Code channel. Guys, in today's session, we'll see how we can create virtual links between different areas, right? So, why do we need a virtual links? By design, OSPF area 0, it should be connected to all the OSPF areas, all the regular OSPF areas, but sometimes it is not feasible for us to connect all the areas to area 0. So in that kind of condition, our OSPF environment cannot provide end-to-end connectivity. Okay, so in that case, we have one workaround to connect new areas or other areas to area 0. For example, in our scenario, for example, we had existing environment area 0 that was already connected to area 1. Now we have to add one more area 2. Okay, it is not possible for us to add area 2 towards this hand side to R4. Okay, so we had to connect area 2 to area 1. So this kind of environment will not work. So we will have to use the workaround by using a virtual link command so that we can have end-to-end connectivity. So now let's see how we can create a virtual links in our OSPF environment. I have already configured the IP addresses. Let me show you. Show IP int brief. Okay, on in R1 we have only one IP address 12.1.1, and on R2 show IP int brief. Okay, on R2 we have two interfaces in one 12 network and other is 23 network. And let me show you on R3 also 23, 34 and 23. So this is 34 and this is 23 interface. And on R4 we have only one interface, that is 34. Okay, so let's configure OSPF on all the routers as per the area. Interface, let's go to router OSPF1 network 12.1.1.0.0.0.0.255 area. So here we will keep it in area 2, right? Router ID 1.1.1.1, right? Okay, and now let's go to R2 config T router OSPF2 router ID 2.2.2.2 network 12.1.1.0.0.0.0.255. This we are going to put in area 2, and the other interface that is in 23 network, this we will put in area 1, and right. Show IP OSPF neighbor. Neighborship is in two-way state yet. Config T router OSPF 3 router ID 3.3.3.3. Uh, let's check if we had configured router ID on previous routers. Yes, we have. So R3 will be in area 0 and area 1. So in area 1 will be 23.1.1.0.0.0.255 area 1, and 34 will be in area 0. We have a full neighborship done on R3 and right. And now let's go on R4. R4 config T router OSPF4 router ID 4.4.4.4 network will be 34. 34.1.1.0.0.0.255 area will be 0. Enter and right. Show IP OSPF neighbor. So it's in a two-way status. show IP OSPF neighbor, and towards 4.4.4 it is in X start state, right? Show IP OSPF neighbor full state, show IP OSPF neighbor full state. Okay, DR is elected between 1 and 2, and 2 is DR router R2. Okay, and here the R2 is mm, BDR. No, R3 is BDR and R1 is BDR. R2 is DR for both the networks. And let's check on R3 also. They are in full state. Okay, and uh, 4.4 is DR and 2 is also DR. Show IP OSPF neighbor. Okay, if I do show IP route, right? Let's see if we have end-to-end connectivity. So now R4 knows about 34 network and 23 network. R4 area is sharing the routes with area 1, right? It doesn't know about area 2. It doesn't know about area 1. So let's see what is the condition on R3. So R3 knows about 34 and 23, right? R3 knows about two areas, but not about 12. Show IP route, and R2 knows about 34 area, and 34 area, 23 and 12. 34, 23 and 12. And let's check on R1. Show IP route. R1 is not getting any routes from uh, area 1 on area 0, right? Because here R3 is ABR. Okay, it is sharing all its routes with area 0, but this R2 is not sending any routes further to R1 because R2 is not connected to area 0. This area 2 is not connected to area 0. So R2 is not sending any routes to area 2. So in that kind of condition we will have to create virtual links between R2 and R3 so that R2 shares this area shares all the routes with area 0. Okay, so let's see what is the command to uh, configure virtual links. So we will do configuration of virtual links between R2 and R3 so that this router picks up the this area 0. It has connectivity with area 0 through a logical link or virtual link, right? So the command will be, let's go into a router OSPF 2 area. So here we will use the area ID that is the in transition in the path, right? So here area ID will be 1, and then we will use the command virtual link. Now virtual link with which neighbor router? So here we will use the uh, router ID of R3. So that is 3.3.3.3, and same command we will run on R3 also. Config T router OSPF 3 area 1 virtual link. Here the router ID that will be used for R2 because we are creating virtual link, one from R2 to R3, other from R3 to R2. So it will be 2.2.2 end. Right here we got the message that received invalid packet, mismatch area ID from backbone area must be virtual link but not found from 23.1.2. Okay, and after giving the this command, it again created the neighborship, and loading is full. Now let's do a show IP route. Okay, now we should have end-to-end connectivity. Show IP route. Okay, now we can see that it R1 is getting all the routes now. So let's compare it with the uh, output we had earlier. Earlier it knew only about 12 network. Okay, there were no routes coming from area 0 or area 1, because R2, this area border route, this was not area border router, because any border router that is connected to area 0 will share the routes with other routers, right, other areas. If any border router that is not connected to area 0 will not share routes with other areas. So now we have created the virtual link, we have provided connectivity with area 0. Now it is getting all the routes. Now it has connectivity with area 0 and it is getting all the routes, right? So now there is end-to-end connectivity. We can check with ping 34.1.1.4, and we have end-to-end connectivity. Ping 12.1.1.1. We can also verify the virtual links that we just created. Show IP OSPF, and here we have option virtual link. Okay, here we can see that we have virtual link VL0 OS. This is the name of a link OSPF VL0 created with the router 2.2.2, that is up. Okay, and this is also called run on demand circuit, right? And it has also do not age LSA bit enabled. This bit is set to on whenever we configure virtual link between two routers. So we can check these options also. Transit area is area 1. This is the transit area that falls in between area 2 and area 0. Via interface fast Ethernet 01. Okay, we are on R3, so to connect to R3, it will use the fast Ethernet connection, fast Ethernet 0/1, and cost will be 10 for fast Ethernet connections. 10 cost is used by default. Okay, and see here, interesting thing is that by default fast Ethernet connections are broadcast, right? But in case of virtual link, it uses the virtual link ID that never goes down, because this router ID will never go down, so it consider itself as a point to point. Okay, and these are the hello and dead intervals that will be used as same as that of fast Ethernet, and these are that's all about virtual links. So we can check the same thing on show IP OSPF virtual links. Here we also get same information. OSPF VL0 connected to router 333 and run on demand circuit. Do not age LSA bit is set to on. Okay, and transit area is 1, and interface fast Ethernet, using interface fast Ethernet on R2, and cost of the network is 1, because this is fast Ethernet connection. This is the fast Ethernet connections have cost 10. Okay, so guys, this was about how do we configure virtual links in OSPF whenever we want to connect any non-contiguous area to area 0, right? Please let me know in the comment section if you like this video, and don't forget to like the video. Thank you for watching this video.